Hello, everyone. Welcome back to day 33 of Coding Every Day. Today is a Monday, February 17th, 2025 at 7:40 p.m. And today we're going to look at this graph problem here. So I'm in the graph section. I've kind of been, I've been trying some of these off camera, and it's getting pretty challenging for me. So I'll see what I could do here. So this one, Pacific Atlantic water flow, is a graph problem. I think I have an idea of where to get started. So we get a rectangle of heights, and then anything that's in the top row or the leftmost column is connected to the Pacific Ocean, and anything that's in the rightmost column or the bottom row is connected to the Atlantic Ocean. So water can only flow from a higher height to a lower height. So for instance, if we have water at this tile here, 4, it can flow to 2 because 2 is lower than 4, but it can't flow to 7. This 7 tile, though, if there's water here, it could go to 4, 4, or 6. So we want to return all cells where water can flow from that cell to both the Pacific and Atlantic Oceans. So in this example, everything highlighted in yellow can flow to both oceans. So if we look at 7, so it can just easily flow into the Pacific Ocean, and then to get to the Atlantic, it could do several different paths, but one would be 7, 6, 5 Atlantic, for instance, or 7, 6, 4, 3 Atlantic. And then 4 can just go into both of them instantly. So that's basically the idea. So I think the way I want to approach this is we know all of these at the top can flow into the Pacific Ocean no matter what because they just go into the ocean. Same with the left. And then the inverse is true, or I guess the opposite is true with the, or the same thing is true for the opposite tiles on the bottom and the right for the Atlantic Ocean. So maybe we could have like 2 sets. So I tried this one previously and got stuck. And then I think I looked at the solution for this one. I don't really remember it fully, so we can see if I can, code it. So I think we want 2. Okay, so if we mark, like if we have an array of elements, let's say like something like that. Is that what it has? And then one here. Okay. So if we say Pacific is blue, so we know that all of these, it's a little harsh. So all of these are Pacific and all of these are Atlantic. And then we'll say yellow if they can do both. So in every solution, no matter what, the top right corner and the top left corner will be in the solution. So there has to be at least 2 tiles. And then gray will just be like, we don't know. So, all right. So if we look for, I'll draw it in white, I guess. Sorry, the colors are kind of intense. 4, 2, 7, 3, 4. I'm going to change this to green. Okay, 4, 2, 7, 3, 4, 7, 4, 6, 4, 7, and then I'll just 6, 3, 5, 3, 6. Okay. So if we want to figure out if any tile can get to both, I think a good way to approach this problem would be figure out all tiles that the Pacific Ocean can reach, figure out all tiles that the Atlantic Ocean can reach, and then see which tiles are in both of those sets. So for instance, before we do anything with the water, everything that's in blue or green, we know the Pacific can reach, and then everything that's in purple or green, we know that the Atlantic can reach. So if we just take the intersection of those two sets, then we have these two green tiles here, which are part of the answer. So we can kind of extrapolate that process with the heights and the water. So if we just, so let me make a copy of this. Okay. So let's put everything, let's just look at just the Pacific Ocean for now. Okay. So we want to color in everything that can be in the Pacific Ocean. So how we do that is, I think what we should do is take a tile like 2, and then if it's greater than that tile, it means it can flow into it. So for instance, if we look at this edge right here, 2 and 4, so when we explore 4, we see that 4 is greater than 2. So that means in the context of the problem, 4 could flow into 2, which means that this tile is part of the Pacific Ocean. Yes, Pacific Ocean. And then we can kind of keep searching that way. So 6 is also greater than 4 now. So 3 is not greater than 4. So that means from this tile at least, 3 cannot reach the Pacific Ocean. So we'll keep kind of depth first searching with that. So this is where that one ends. So none of these can flow into the 6. Okay, then we'll look at 7. All of its neighbors are already in the ocean. 3, all of its... Okay, so then when we get to 3, we see 4 here is greater than 3. So that means this is accessible to the Pacific Ocean. And now if you can get to this tile, that means you can get in the Pacific Ocean as well. So then 7 is greater than 4. And that's it for that. So then 4 is surrounded, 7 is surrounded, 4, so 3 is not bigger than 4, so this tile can't get in. 6, none of these are bigger, 4, none of those are bigger, 7, none of those are bigger. Okay, so this is everything, and then if we look at 6, none of its neighbors are bigger that are not in the Pacific Ocean. So we have mapped using that every tile that can get into the Pacific Ocean. Okay, so now let me just bring this up a bit. All right. So now we could do the same thing with the Atlantic Ocean. So I'm going to make everything gray. Okay, so we know that these all start by definition of the problem in the Atlantic Ocean. So 4, none of its neighbors are bigger than it and not in the Atlantic Ocean. Same with 7. 6 is surrounded. Now 3, 4 is bigger than it, so that means 4 can flow into 3. And then if we're doing a depth first search, so 6 is bigger than 4. 7 is bigger than 6. And that's the end for that DFS. So then we'll go to 5. Nothing. 3, 4 is bigger than 3. 7 is bigger than 4. And it ends there. And then 6 is surrounded. So this is everything that's in the Atlantic Ocean. So so I'll delete this one. So if we can figure out those two parts, let me zoom out here. So if we can figure out those two parts, then, based on which tiles are in both sets, is our answer. That's what we're going to return. So if we look, I'll make them all gray first. Okay, so if we look what's in both of them, so this one is, the whole middle row is, and then this one. So these are the tiles that are in both sets, and if we look, that matches up with the test case. Okay, so let's do that. Is it just class solution? Isn't there usually an init method? Okay, I guess I'll write it. So what's it taken? Heights. Is that it? Takes in another thing. Okay, let me go get it from LeetCode, I guess. Code. Oh, it doesn't use the init function, I guess. Okay, perfect. So now we can begin coding. So we can have a function called DFS, or I guess. So it's the same exact code for both C's. So we could just call it explore C, which takes in starting positions. Okay, so first what we have to do is get, so what I want to do is so with our DFS we have to add, so when we're figuring out what goes in the Pacific Ocean, we have to add all of these to a list or to the stack. So it'll take a stack. All right, so first let me just get into, so Pacific stack and Atlantic stack. All right. So we're going to say for I in range, length of heights, and for j in range, length, heights, 0. So if it's in the top row, so if I equals 0, or if it's in the top row or the leftmost column, so if I equals 0 or j equals 0, then we want to add it to the specific. So I guess we could just add the position ij. And then if I equals length of heights -1 or j equals length heights of 0 -1. So if it's in the if it's in the last row or the last column, then Atlantic stack dot append ij. Okay, so let me print those two. Okay, so all the zeros and then 1 0 2 0. 0 4 1 4 2 0 2 1 2 3 2 4. Okay, that looks right. So now we want to explore. So, okay, let's put this above here. So we want to explore a C given one of those stacks. So we'd say like explore C given Pacific stack, for instance. So now we're just going to DFS and then do we want the height as well? Yeah, we probably want the height as well. Okay. So what I would do normally is like this, and then so we're going to pop from the stack, and that'll give us a row and a column, and then we're going to check all 4 cardinal directions, which are new R and new C, so plus delta C. So left is same row, minus 1 column. Up is minus 1 row, same column. Right is like that. And down is plus 1 row, same column. Okay. So what we want to do is check if, so yeah, we're going to need height here. So when we append it to the stack, we'll append ij and then heights of ij like that. And same here, heights of ij. So now we'll get row, column, and height. So if my height is less than or equal to heights of new R, new C, then that means we add it to the Atlantic. Or, sorry, Pacific in this case. So this would be like if we're at 2 and we see that my height 2 is smaller than 4, for instance, then we should add 4 to the stack. So we'll say stack dot append new R, new C, and heights at that. Okay, so we also want to, so if we encounter that, let's have, maybe we'll call it like ocean, or we could just call it visited. And we'll say visited.add new R, new C. And then we also want to check if it's bounded. So if it's not bounded, new R, new C, then we'll just continue to the next one. And also if new R, new C in visited, then we can continue. Okay, so let's make a little bounded function. So it'll take in a row and a column. Then it will return the Boolean expression r less than or equal to length of heights, and 0 less than or equal to column, which is less than length of heights 0. All right. Okay, so when we explore a C, we'll also pass in an empty set. And then maybe we can just say Pacific. Okay, so print. So I'm just going to print these out. Pacific set, Atlantic set. So we will return visited. See if I get any errors. I don't have commas. Okay, so it's telling me Pacific. There's like a set intersection method, right? There's some way that you can check. Is this the ones that are in both of them? So 2, 4. One, 2, row 1, column 2, 1, 1, 2, 0, 1, 4. One, 2, 3, 4, 5, 6, 7, 8. So why is 2, 4 in there? So 2, 4 is not in this set. Okay, 1 second. I'm going to Google set intersection method. Okay, so it's just Pacific set dot intersection Atlantic. One, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, let's see if these are right. So 1, 2, row 1, column 2, 0, 1, 2. That's correct. 0, 4. That's correct. 0, 0 is correct for Pacific. Okay, so which ones am I missing? So 1, 2, 1, 2, 1, 1, 1, 4, 1, 3. So 1, 0, 1, 2, 1, 3, 1, 1, 1, 4. So all the ones are in there. 0, 2 is in there. And that's it. Okay, so these two are not in there, basically. So it's missing the corners. Oh. It's because it shouldn't be an empty set. We should pass in the set version of Pacific Stack. Okay, so now this one has the heights in it, and the other one doesn't. So I could make visited have the heights in it, or I feel like that's unnecessary information. And then so 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 1, 2, 3, 5. And then it has 2, 0, 0, 2, and 0, 4. Okay, so this is the correct that's correct. So then it wants okay, so I just need to figure out my data structures here. And then it wants a list of integer. All right, so let's figure out the data structures here. So visited should definitely be a set because we need to look it up in O of 1. This doesn't necessarily have to be a list. It could be a set because the order we explore it doesn't really matter. Okay, so let me just make them a set. And then we can pass in 2 copies of the set. Or the first one can be so the second one will be a copy like that. Okay, yeah, but the only problem with that is, so this one so in visited we don't want the heights. Okay, so this is the, but now these ones do have the heights. Yeah, so those are a bit tricky. Okay, I think it's probably better to just have everything have the heights like this. Okay. And then we can just say Okay, so 4 pair in the intersection. So we want to list res.append pair of 0, pair of 1 inside a list like that. Okay. So instead of this, could I say explore C dot intersection Pacific at Atlantic, and then all right, so we'll just abbreviate it to 4 like this. All right. Set object has no, is it a parenthesis issue? So this is returning a set. Did I spell it wrong? Yeah, intersection. That's okay. Can I do this? That probably isn't very good. I feel like there's an easier way to do this, but it's probably just best like this. Okay, so I have this solution. I'm just trying to think if I'm wasting any memory. So I don't know. Because we need the visited and then we need the stack. I just don't know if we need two separate sets. All right, so I'll just comment it. So traverse through ocean and mark any traverse through ocean, return everything visited. And then we'll say return intersection of Pacific visited and Atlantic visited. Intersection. Generate starting Pacific sets is top and left, and Atlantic is right and bottom. Okay, so I guess I'll just leave it like this. Yeah, I think I'm pretty happy with that. I don't know if I'm wasting any memory, but I did solve the problem. I think that's something I'm realizing is I'm kind of hyper fixating on performance and optimization, which is fine, but I shouldn't let it get in the way of actually solving the problem itself. So it's good to just kind of do a naive or inefficient solution and then narrow it down from there instead of never doing anything because you're too worried about optimizing. Yeah, all right, so that's Pacific Atlantic water flow. Thank you guys for watching, and I'll see you tomorrow.